Welcome to an introduction to Distributed Denial of Service or DDoS Protection. In this session, we'll explore how to defend against distributed attacks. A distributed denial of service attack is a type of cyber attack where multiple compromised systems are used to disrupt the normal traffic of a targeted server, service, or network by overwhelming it with a flood of traffic. This makes it unavailable to legitimate users. Let's dive in to understand how these attacks work and what we can do to protect against them. Let's examine the different types of distributed denial of service attacks. These attacks can be broadly categorized into three main types: volume-based attacks, protocol-based attacks, and application layer attacks. Volume-based attacks aim to overwhelm the bandwidth of the target network. Protocol-based attacks exploit weaknesses in server resources to disrupt services. Application layer attacks target specific applications, often using seemingly legitimate requests to overwhelm the server. It is important to understand these different types of attacks in order to implement appropriate protection measures. The Open Systems Interconnection, or OSI, model is also shown with the layers highlighted where these attacks are most common. Volume-based attacks mostly affect Layer 3, or the network layer. Protocol-based attacks mainly affect Layer 4, or the transport layer. Application layer attacks target Layer 7, or the application layer. Here are some common attack vectors that are used in distributed denial of service attacks. A UDP, or User Datagram Protocol, flood involves sending large volumes of UDP packets to random ports on a target server. A SYN, or Synchronized Sequence Numbers, flood exploits the Transmission Control Protocol, or TCP, handshake process by sending a flood of synchronized requests without completing the handshake. An HTTP, or Hypertext Transfer Protocol, flood overwhelms web servers with a large number of HTTP GET or POST requests. A DNS, or Domain Name System, amplification attack uses publicly accessible DNS servers to amplify the volume of attack traffic directed at a target. Here's a sample Python code to detect SYN flood attacks by monitoring half-open connections. It's very important to understand the business impact of distributed denial of service attacks. The financial loss can be significant, with an average cost of downtime for e-commerce platforms being several $1,000s per hour. User impact is also substantial. After experiencing slow load times, a large percentage of users will abandon their session. Brand damage can be long-term, as customer trust and reputation recovery often takes months. Here's a downtime cost escalation chart, which shows that the cost of downtime increases exponentially with the duration of the attack. The cost starts from $93 per minute, increasing to $134,000 per day. The approximate downtime cost can be found using the formula: cost equals revenue per hour times downtime times recovery factor. The following are some key detection methods used to identify distributed denial of service attacks. Traffic volume analysis involves monitoring bandwidth usage and packet rates to identify unusual spikes that may indicate an attack. Pattern recognition techniques are used to identify suspicious traffic patterns and source distributions. Baseline comparison involves comparing current traffic metrics against historical data to detect anomalies. Signature detection involves matching traffic against known attack signatures and patterns. Here's a traffic anomaly detection example. If the current traffic is more than 3 times the baseline traffic, a potential DDoS attack is detected. Let's review the prevention strategies for distributed denial of service attacks. Capacity planning involves over-provisioning bandwidth and server resources to handle unexpected traffic spikes. Traffic filtering involves implementing rate limiting, IP filtering, and geo-blocking at the network edge to block malicious traffic. Infrastructure redundancy involves deploying across multiple data centers with load balancing capabilities to ensure high availability. Defense in depth is another important strategy, which involves implementing multiple layers of security to protect against attacks. Proactive measures such as regular capacity testing, incident response planning, security monitoring setup, and vendor partnership agreements are also helpful in preventing distributed denial of service attacks. Here are some mitigation techniques that can be used to respond to distributed denial of service attacks. Black hole routing involves routing malicious traffic to a null interface, effectively dropping the packets. Rate limiting involves restricting the number of requests per IP address within a specified time window. Traffic scrubbing involves filtering legitimate traffic from malicious attack traffic. Failover activation involves switching to backup infrastructure during attack periods to maintain service availability. Here is a sample token bucket rate limiter implementation. If the number of tokens is greater than 0, the request is allowed. These are the common infrastructure solutions for distributed denial of service protection. Content delivery networks, or CDNs, distribute traffic across global edge servers to absorb attack volume and reduce the impact on the origin server. Load balancers distribute incoming requests across multiple backend servers to prevent any single server from being overwhelmed. Anycast networks route traffic to the nearest available server using Border Gateway Protocol, or BGP routing, providing redundancy and reducing latency. The architecture diagram displayed shows a distributed architecture that includes content delivery networks, a load balancer, and multiple servers. This architecture provides geographic traffic distribution, automatic failover capabilities, reduced latency for users, and improved fault tolerance. Cloud-based protection provides scalable and reliable distributed denial of service protection services. AWS Shield is a managed distributed denial of service protection service with always-on detection and mitigation capabilities. Cloudflare is a global network with automatic distributed denial of service protection and web application firewall, or WAF, capabilities. Azure Distributed Denial of Service Protection provides built-in protection with adaptive tuning and attack analytics. These cloud providers offer multi-layer cloud defense. The edge protection layer, traffic scrubbing centers, and application protection are all the parts of multi-layer cloud defense. These cloud providers has network capacity of hundreds of terabits per second, serves hundreds of cities across the world. The detection time is less than 3 seconds and mitigation time is less than 10 seconds. These are the different monitoring and analytics tools for distributed denial of service protection. NetFlow Analysis provides real-time network traffic monitoring and flow analytics to detect anomalies. Security Information and Event Management, or SIEM, integration allows for correlation of security events from various sources to identify attacks. The Elastic Stack, which includes Elasticsearch, Logstash, and Kibana, is used for log analysis and visualization. Prometheus is used for time series metrics collection and alerting. Here's an example of a traffic monitoring script. If the current byte per second is more than 5 times the baseline byte per second, then it triggers an alert. An incident response plan is the key for effectively managing and mitigating distributed denial of service attacks. The detection phase involves automated monitoring that triggers alerts when attack patterns are detected. The assessment phase involves analyzing the attack type, scale, and impact on business operations. The response phase involves executing mitigation strategies and activating backup systems. Here is a sample response timeline which shows the time taken by each phase. The goal is to complete the detection within 3 minutes, assessment within 8 minutes, mitigation within 15 minutes, and recovery within 30 minutes. These are some service level agreement or SLA targets. Detection time should be less than 3 minutes. Response time should be less than 15 minutes, recovery time should be less than 30 minutes, and communication should be done in less than 5 minutes. Here is the summary of best practices for distributed denial of service protection. Preparation involves developing comprehensive incident response plans and backup strategies. Continuous monitoring involves implementing 24/7 monitoring with automated alert systems. Regular testing involves conducting periodic stress tests and simulating attack scenarios. Team training involves training security teams on the latest threats and response procedures. Prevention, detection, response, and recovery are the components of a holistic security framework. A multi-layered defense approach, proactive monitoring, cloud solutions, and incident response plans are critical. Regular testing and updates are essential. Congratulations! You have completed this module on distributed denial of service protection. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.